Welcome back, welcome back. We are on lesson 6.5, prove triangles are similar by side, 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 and side angle side similarity. I'm going to try to keep the video shorter by going through things and asking you to pause the video and do it on your own. So please make sure you've got your vocab sheet open or here and your book open to page 388. Today we're talking about two similarity theorems, two ways to show that triangles are similar, not congruent, but similar. The first one's real basic, so I'd like you to look on page 388, and I would like you to complete all three boxes here of your vocab sheet. So you're going to be making a sketch of the concept, all which can be found on that page. Write down the properties that are true, and maybe give an example, and then state the theorem in your own words. So go ahead and pause the video and complete that. Now we're going to look at our first example. First example, and I'd like you to write your answers to this on a piece of paper because we will reference this in class. But if you take a look at this problem, it says find the value of x that makes triangle ABC similar to DEF. Well, in order for them to be similar, notice the only information given are the sides. So we need to consider the side, side, side similarity theorem. Notice that AB aligns with DE. So AB is 4, DE is 12. So 4 is to 12 reduces down to a 1:3 ratio. So that means that these sides have to all be in the 1:3 ratio for them to be similar. So if it's given that EF is 18, if we fill in the blanks here, what must the corresponding side with 18 be in order to stay in the 1:3 ratio? Well, notice it must equal 6. So therefore, to finish this up, we're just going to solve this. X minus 6 has to be equal to 6, so that means x is 7. Then if we double check this, if we plug 7 back up here into side DF, that would make side DF 7 plus 1 is 8, 8 times 3 is 24. Notice that it corresponds with side 8. So 8 is to 24, as 6 is to 18, as 4 is to 12. And with a little bit of arithmetic, you can see that that all reduces to a 1:3 ratio. So they are similar. Okay, the next one I'd like you to look at and then try. I'll zoom in on it, and you are going to have to write the solution to this, a detailed solution, and I will check it first thing tomorrow. So which of these three triangles are similar, and write a similarity statement. So I'll zoom in here so that you can see this. This, I believe, is a 26. So pause the video, write out your detailed solution, and I will check that first thing tomorrow. Okay, next one we're going to look at. It says the shortest side of a triangle that's similar to RST is 12 units long. Find the length of the other sides of the triangle. Okay, so there's some other mystery triangle out here that's similar to this, and the shortest side is 12. Well, looking up here, the side that's 12 would have to correspond with the 24. So we can figure out our scale factor. 12 is to 24 as 1 is to 2. So we're in a 2-to-1 ratio here. So you can do a little bit of math here to stay in the 2-to-1 ratio with 30. And with 33, you would get 11 and 15. Okay, should be pretty straightforward. Okay, now we're going to jump to side angle side similarity. So if you'll turn in your book to page 390, and please pause the video and do the same thing, fill out these boxes exactly, and then we'll come back and look at one. Okay, we can put this up here now. Here's our problem for side angle side similarity. You are building a lean-to shelter starting from a tree branch as shown. Can you construct the right end so it is similar to the left end using the angle measure and the lengths that are shown. Well, taking a look at this, we've got the included angle is 53. So when you're using side angle side similarity, just like with side angle side congruence, the two sides have to be the two sides that come together to make the angle of 53 degrees. So 6 is to 9 as 10 is to 15. Okay, so we have to see if those are in the same ratio. So 6 is to 9 as 10 is to 15. You can do a couple different things. You can check cross products. Does 6 times 15 equal the same as 9 times 10? And in this case it does. So that means these are in the same ratio. You've got side angle side similarity. Okay, the last two problems. You'll have to pause the video as you go through this. But tell what method you would use to show that the triangles are similar. And I apologize, I had gone through this once before on a video that didn't work, and I already marked those. But in your homework, those will not be marked. But since I marked them, that should give you a clue on the reasonings. Now, kind of like a proof, you're going to have to tell me why are these congruent. And you're going to have to show something to show that the sides are in the same ratio. So can you please write the steps and how you would know that triangle ABC is congruent to or is similar to what other triangle, and make sure your congruent statements are the same. Okay, I will check that first thing tomorrow. And the last one, we're going to go down to this one. Explain how you would show that triangle XZW is similar to triangle YZX. And again, make sure that you're saying things like this is congruent to this because of the triangle sum theorem, or because they are vertical angles, or because definition of right angles. Make sure that you are using some logic there. Okay. Alright, and we are done with the video, so make sure that you have that complete, and we will see you tomorrow.